Hello friends and my dear students, I welcome you all to my channel. So this is part 3 video on the chapter of linear equations where I will solve the remaining problems of exercise 8B, that is problem number 13 to problem number 27. If you have not watched the previous two parts on the video on this chapter linear equations, I strongly suggest and request that you please watch them to maintain the continuity of your study on the chapter of linear equations. So this video is part of the playlist CBSE Maths for class 8 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest that you support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future video. So let's get started with this video. Okay, so I have the problems number 13 to 27 on the left hand side from exercise 8B, and I will solve the problems on the right hand side. I hope the problems may not look that big, but I hope it's readable. It's big enough so that you can read the problems. Okay. Problem number 13. The denominator of a rational number is greater than its numerator by 7. Okay, if the numerator is increased by 17 and the denominator decreased by 6, the new number becomes 2. Find the original number. Okay, so let the denominator of a rational number is greater than its numerator by 17. Okay, so let the numerator of original number be x. This implies, as per the given problem statement, denominator of original number is equal to it is greater than the numerator by 7. So x plus 7 is the, so this implies original rational number will be p by q, that is numerator divided by denominator. So it will be x by x plus 7. This is the original rational number. Okay, if the numerator is increased by 17 and the denominator decreased by 6, okay, now the rational number is equal to the numerator is increased by 17. So the numerator in the original number was x, so it has been increased by 17. So the numerator of the new rational number becomes x plus 17, and the denominator has been decreased by 6. So the denominator in the original rational number was x plus 7, and now in the new number it has been decreased by 6. So this is the new number, and it is given that the new number is equal to 2. So we can say that x plus 17 divided by x plus 7 minus 6 is equal to 2. So this is the equation we have formed based on the given problem statement, and we have to do, let's do a little bit of simplification in the denominator part. We have x plus 17, the denominator becomes x plus 7 minus 6, which is x plus 1. This is equal to 2. Now we will do cross multiplication. This kind of equations where the LHS or the RHS is a rational form, where both the denominator and the numerator has the variables. We do cross multiplication. So 2 can be expressed as 2 by 1. So by cross multiplication, we can say that 1 multiplied by x plus 17 is equal to 2 multiplied by x plus 1. This implies if we do the products and open the brackets, we get x plus 17 is equal to twice of x plus 1. Now this implies by transposition, if we bring all the x terms, that is the variable terms on the left hand side, and all the constant terms to the right hand side, we get x minus twice x is equal to 1 minus 17. This implies we get further simplification of the LHS and RHS, we get minus x is equal to minus 16. This implies x is equal to 16. So the numerator of the original number is 16. So this implies original rational number. It has asked the original number. So original rational number then becomes equals to x by original rational number was x by x plus 7. So it will be 16 by 16 plus 7, which is equal to 16 by 23. So this is the original. So this is the original rational number. As always, I say that I may make calculation mistakes. I'm not really focusing in calculation mistakes, so my results could be different. It may not match with the actual answer because I have not seen the answers. So just focus in the concept I am applying to solve the problems, and the methods I am also the methods or the rules I am applying to solve the linear equation. Understanding the problem, translating the given problem statement into an equation, and then solving the equation. These are the major steps. Okay, let's do problem number 14. In a fraction, twice the numerator is 2 more than the denominator. In a fraction, twice the numerator is 2 more than the denominator. Okay. Twice the numerator is 2 more than the denominator. If 3 is added to the numerator and to the denominator, the new fraction is 2 by 3. Find the original fraction. Okay. So you can assume anything you wish. That is, you can assume either the denominator or the numerator of the original fraction. So let the denominator of original fraction b, let's say p, no, not p, but let's say q. Usually we denote a fraction or rational number in the form p by q. So let's say the denominator of the original fraction be q. Now what can we say about the numerator? Because there is a relation given. Okay, so that in a fraction twice the numerator is so if a numerator, let's say if numerator is p, this will imply as per the problem statement, twice the numerator, that is twice p, is 2 more than the denominator. Denominator is q, so q plus 2. So this implies that p is equal to q plus 2 by 2. This is the numerator. So numerator is q plus 2 by 2 and the denominator is q. So we have only single variable, that is q. This implies Uh, okay. Now, if so, the original fraction, we have to ultimately find the original fraction. So, original fraction is P by Q, where we know that P is equal to Q plus 2 by 2. Okay. So, let P is equal to Q plus 2 by 2, and we have divided by Q. This is equal to Q plus 2 divided by twice Q. This is the original fraction. Once we have found Q, we can say that the original fraction will be Q plus 2 by divided by 2 in twice Q. Okay. Now it is given that if 3 is added to the numerator and to the denominator, the new fraction is 2 by 3. Okay. Now, what is the new fraction? New fraction will be, new fraction is 3 is added to the numerator and to the denominator. So, new fraction will be P plus 3 divided by Q plus 3, where we know that P is equal to Q plus 2 by 2. P we know is equal to P is the numerator of the original fraction, and Q is the denominator of the original fraction, and we know that P is equal to Q plus 2 by 2. So the new fraction will be P plus 3 divided by Q plus 3, as 3 has been added to both the numerator and the denominator of the original fraction. Now P we know is Q plus 2 by 2. We have plus 3 divided by Q plus 3. This is the new fraction, and the new fraction is given to be 2 by 3. 2 by 3. So we have this equation form where we have to solve this is a linear equation, not linear equation. So this is the equation we have formed based on the variable Q. So if we can find from this equation, we will find Q, and once we have found Q, we can also find P. We can also find P because P is equal to Q plus 2 by 2. Okay, now we have to solve this equation. Now let's do a little bit of a simplification of the LHS. Q plus 2 divided by 2 plus 3. If we simplify that, it becomes Q plus 2 plus 3 into 2 divided by 2, and we have divided by Q plus 3 is equal to 2 by 3. After further simplification of the LHS, we get Q plus 2 plus 6, that is Q plus 8 divided by 2 into Q plus 3 is equal to 2 by 3. Now we will do cross multiplication to solve the equation in Q, and we get, after cross multiplication, we get 3 multiplied by Q plus 8 is equal to 2 multiplied by 2 into Q plus 3. So after doing the products, after simplifying both the LHS and the RHS, that is doing the products and opening the brackets, we get 3Q plus 24 is equal to 4Q plus 12. 4Q plus 12. Now bringing all the Q terms to the left hand side and all the constant to the right hand side, we get 3Q minus 4Q is equal to 12 minus 24. This implies minus Q is equal to minus 12. This implies Q is equal to 12. So Q is 12. Now we can also find P. P is equal to Q plus 2 divided by 2. P we have already found to be Q plus 2 divided by 2. So P will be equals to 12 plus 2 divided by 2, which is 7. This implies we have found P and Q, and hence the original fraction is equal to P by Q, which is equal to 7 by 12. 7 by 12 is the original fraction. Okay, let's do problem number 15. Problem number 15. The length of a rectangle exceeds its breadth by 7 centimeter. If the length is decreased by 4 centimeter and the breadth is increased by 3 centimeter, the area of the new rectangle is the same as the area of the original rectangle. Find the length and breadth of the original rectangle. Okay, so let the breadth be x. It is given that the length of a rectangle exceeds its breadth by 7 centimeter. So I am ignoring the units. It is obvious. Please note that all the units will be in centimeter. So let the breadth be x. This implies length is given to be 7 more than the breadth, that is x plus 7. This implies area of the rectangle will be breadth, we know, breadth multiplied by length, which will be equal to x multiplied by x plus 7. Okay, so this is the original area of the rectangle. Now if the length is decreased by 4 centimeter and the breadth is increased by 3 centimeter, the area of the new rectangle is the same as the area of the, okay, so new breadth is equal to breadth has been increased by 3, so new breadth is x plus 3, and new length is equal to length has been decreased by 4, so original length was x plus 7, and from that 4 has been decreased, so this becomes x plus 3. So new area of the rectangle will be new breadth into new length, that is x plus 3 multiplied by x plus 3, which is equal to x plus 3 whole square. Now it is given that new area is equal to the original area, so we have x plus 3 whole square is equal to x multiplied by x plus 7. So this is the equation we have got. We have formed in the variable x, even though it may not look like a linear equation, but it will get reduced to a linear equation if we do the squaring of the LHS and if we simplify the RHS by doing the product. So if you do the squaring of the LHS using the formula a plus b whole square is equal to a square plus b square plus twice ab, and the right hand side becomes x square plus 7x. This implies you can see that. Okay, now let's bring all the variable terms, that is the x terms, to the left hand side and all the constant terms to the right hand side, and we get x square plus 2 into x into 3 becomes 6x, and we bring from the right hand side x square and 7x, and on the right hand side we have minus 3 square, which is minus 9. Now, if we simplify the LHS, x square gets cancels out and we get minus x is equal to minus 9. Hence, we get x is equal to 9. So, the breadth is x. Breadth is x. So, therefore, it has asked the find the length and breadth of the original rectangle. Okay. So, length is equal to x plus 7, because the original breadth we assume to be x, and the length was x plus 7 as per the given information. So, length of the original rectangle will be 9 plus 7, 16, and breadth is equal to is 9. So, the length is 16 centimeter and breadth is 9 centimeter of the original rectangle. Okay, let's do problem number 16. The width of a rectangle is 2/3 its length. Okay, so let length be x. So this implies breadth is given to be the width of a rectangle is 2/3 its length. 2/3 of x, that is 2/3 multiplied by x, that is 2x by 3. So we have assumed the length to be x, and hence the breadth will be 2/3 of x, that is 2x by 3. Okay. Now if the perimeter is 180 meters, find the dimensions of the rectangle. So this implies perimeter of the rectangle is, we know, 4 into length plus breadth. Length plus breadth. This is equal to 4 into length is x and breadth is 2x by 3. 2x by 3. This is equal to, if you simplify the x plus 2x by 3, it will be 3x plus twice x by 3, which further can be simplified as 5x by 3, which is equal to 20x by 3. So this is the perimeter of the rectangle. Now it is given that the perimeter is equal to 180 meters. So this implies 20x by 3 is equal to 180. This implies x is equal to 180 multiplied by 3 by 20. Now you must be very familiar with solving linear equation, that ultimately when you are solving a linear equation in one variable, ultimately in the last step you will get something like a constant k. It is a number, it is a constant k. X is equal to, let's say, k1. K1 is a constant, into x is equal to, on the right hand side you will get another constant k2. So from this you can the x will be equal to k2 divided by k1, which is equal to k2 divided by k1. So if I do a little step by step, this will be, x will be actually equal to 180 divided by 20 by 3. Now 180 divided by 20 by 3 is equal to 180 multiplied by the reciprocal of 20 by 3, which is 3 by 20. This is equal to, if we do cancellation, we have 9, 20, x is 27. So length is 27 This implies the problem has asked to find the dimensions of the rectangle. So length is equal to 27 meter and breadth will be equal to 2 by 3, 2x by 3, that is 2/3 of the length. 2 by 3 into 27 meter. This is equal to 18 meter. 18 meter. So 27 meter is the length and 18 meter is the breadth of the rectangle. Okay, let's do problem number 17. An altitude of a triangle is 5/3 the length of its corresponding base. So we know that in a triangle, the base, when we corresponding base means if this is a triangle, let's if ABC is the triangle, if we consider BC as the base, then the altitude will be the perpendicular drawn from the opposite vertex, that is A, on the base. This is 90 degree. So AD is the altitude, BC is the base, and AD is the altitude of the triangle ABC, and area we know is that area is equal to half into base multiplied by altitude. Okay, this information we know from insulation. Okay, now what is given? The altitude of a triangle is 5/3 of the length, 5/3 the length of its corresponding base. Okay, so let base be, let length of base be x. I'm ignoring the units. Let the length of the base be x. So this implies, as per the given information, length of altitude will be equal to 5/3 of the base, that is 5/3 of x, which is equal to 5/3 multiplied by x, which is equal to 5x by 3. Now, if the altitude be increased by 4 centimeter and the base decreased by 2 centimeter, the area of the triangle remains the same. Okay. Now, the area of the triangle will be half into length is x and the altitude is 5x by 3. So this is equal to 5x square by 6. This is the area of the original triangle. Now it is given that if the altitude be increased by 4 centimeter, so new altitude is increased by 4 centimeter. So the original altitude was 5x by 3 and it has been increased by 4. Okay, so this is the new altitude and the base decreased by 2 centimeter. So new base was originally x and the new base will be x minus 2. So this implies a new area is equal to half into base, that is x minus 2 multiplied by new altitude, that is 5x by 3 plus 4. Okay, so this is the new area and it is given that the new area is equal to the original area, and hence we have to find the base and altitude of the original triangle. So we can say that since the new area is equal to the original area, we have the original area was 5x square by 6. This will be equal to the new area, that is a half multiplied by x minus 2 multiplied by 5x by 3 plus 4. This is the equation we have got. We have to solve this equation, even though it does not look like a linear equation because we have x square on the LHS, but it will get reduced to a linear form if we simplify the LHS and RHS. Now, okay, now how do we solve this? So we can, if we do a little bit of simplification, we have 5x square by 6 is equal to x minus 2. We have x minus 2, and if we simplify 5x by 3 plus 4, it will be 5x plus 12 by 3, and we have outside half. Now this, the RHS, if we do a little bit of further simplification, it becomes x minus 2 multiplied by 5x plus 12 divided by, we have 3 into 2, that is 6. So we have this. Okay, now so we have 5x square by 6 is equal to x minus 2 multiplied by 5x plus 12 whole divided by 6. So both the terms, both the LHS and RHS are in the form of rational form where the denominator is 6. So we will multiply both the LHS and RHS by 6. So we have 6 multiplied by 5x square by 6 is equal to 6 multiplied by, because from the rules of solving a linear equation, we can always multiply both the sides of the equation by a non-zero number. So we have multiplied both the LHS and RHS by 6, and we have this. If we simplify further, we have the LHS becomes 5x square, and also the RHS becomes x minus 2 multiplied by 5x plus 12. Okay, now if we do the product of the RHS and expand, if we do the product and expand the RHS, we get 5x square, it will be 5x square minus 10x plus 12x minus 24. You should be very comfortable in doing the product of two binomials, because the right hand side is x minus 2 multiplied by 5x plus 12. They are, both the expressions are x minus 2 and 5x plus 2, 5x plus 12, they are both binomials. So product of monomials with binomials, product of two binomials, and product of binomials with any polynomials, all these concepts must be very clear, and you should be very comfortable in doing this kind of operations on algebraic expressions. Okay, now we have this. Now clearly we can see now this the right hand side. Okay, now if we will bring all the variable terms, what is happening? Okay, now we will bring all the 5x square minus 10x plus 12x minus 24. Now I will bring all the variable terms to the left hand side, and will keep the constant terms on the right hand side, and I get 5x square minus 5x square plus 10x minus 12x is equal to minus 24. On simplifying the LHS, we get minus 5x square and 5x square cancels out, and we get minus 2x is equal to minus 24. This implies x is equal to minus 24 divided by minus 2, which is 12. So x is 12. That is the length of the original triangle is the base of the original triangle is of length 12 centimeter. This implies a length of base is equal to 12 centimeter, and altitude is equal to it was 5 third of the base, that is 5x by 3, 5x by 3, and x is 12. So it will be 5 by 3 multiplied by 12. This is 20 centimeter. So the base is 12 centimeter and the altitude is 20 centimeter. Okay, let's do problem number 18. Two angles of a triangle are in the ratio 4:5. If the sum of these angles is equal to the third angle, find the angles of the triangle. Okay, so you will need to have a concept about properties of triangle. You know that in a triangle, the sum of the angles is equal to 180 degree. This concept will be applied in this problem. So two angles of a triangle are in the ratio 4:5. So let two angles be 4x and 5x. So this implies third angle will be 180 minus 4x plus 5x, because the sum of the three angles must be equal to 180 degree in a triangle. So if two angles are 4x and 5x, then obviously the third angle has to be 180 degree minus 4x plus 5x. This is equal to 180 minus 9x. This is the third angle. Okay, now it is given that if the sum of these angles is equal to, the sum of the two angles is equal to the third angle, find the angles of the triangle. Okay, if the sum of these angles is equal to the third angle. Okay, so third angle, actually we will not find this way. Third angle is already given to be equal to the sum of these two angles, that is 4x plus 5x, which is equal to 9x. It is given that if the sum of these angles means the two angles which are in the ratio 4:5, and those two angles we have assumed to be 4x and 5x. So the third angle will be 4x plus 5x, which is 9x. And we know that the sum of three angles of a triangle is 180 degree. So we must have 4x plus 5x plus 9x is equal to 180. So this implies the LHS becomes 18x is equal to 180. This implies x is equal to 180 by 18, which is 10. Hence, the angles are, therefore, angles are 4x is 4 into 10. These are all in degrees. 4 into 10, then it will be 5x, that is 5 into 10, and then the third angle will be 9x, that is 9 into 10. So we have 40 degree, 50 degree, and 90 degree. 40, 50, 90 degrees are the angles of the triangle. Okay, let's do problem number 19. A streamer goes downstream from one port to another in 9 hours. Okay, it covers the same distance upstream in 10 hours. Okay, so let's say a streamer goes downstream from one port to another. So let's say the streamer is going from, this is the port 1, and this is port 2. So this is downstream, this is downstream, and this is, let's say, upstream. So down and up. So it is given that the streamer takes 9 hours to go from port 1 to port 2, that is downstream, and it covers and it takes 10 hours to go from port 2 to port 1, that is upstream. If the speed of the stream be 1 kilometer per hour, find the speed of the streamer in still water and the distance between the ports. Okay. It is given that the stream is having some speed. The speed of the stream is 1 kilometer per hour. So speed of stream is speed of stream, let it that be s is equal to 1 kilometer per hour. Now let speed of speed of the steamer in still water be x kilometer per hour. So we are assuming the speed of the steamer in still water is x kilometer per hour. Okay. Now downstream means when the steamer is going from port 1 to port 2, it is downstream, means it is moving along the direction of the movement of the stream. And when the steamer is going from port 2 to port 1, it is going against the stream. Okay. We have to find the distance between the ports and find the speed of the steamer in still water. Okay, we have assumed the speed of the steamer in still water be x kilometer. Okay. Somehow we have to find x. Now so it is given that the steamer takes 9 hours to go from 9 hours. It covers the distance, that is the distance between the port 1 and port 2, in 9 hours downstream. Now please note that we have assumed the speed of the steamer in still water, but when it is moving in the water, the stream is having a speed of 1 kilometer per hour. So its effective speed will change depending on whether it is moving downstream or upstream. So effective speed of streamer downstream will be equal to the speed of the stream will get added with the speed of the steamer. So the effective speed of steamer downstream will be x plus 1. Similarly, the effective speed of steamer upstream, that is when it is moving against the stream upstream, it will be x minus 1, because the speed of the stream is 1 kilometer per hour. Okay. Now it is given that it covers the same distance upstream in 10 hours. Okay. So the effective speed of the streamer downstream is x plus 1, that is x plus 1 kilometer per hour, and upstream is x minus 1 kilometer per hour. So distance covered by streamer or downstream in it is given that the streamer goes downstream downstream in one port to another in 9 hours. So distance covered by streamer downstream in 9 hours will be equal to the effective speed of the streamer downstream multiplied by 9. So x plus 1, 9 into x plus 1. So this is the distance covered by streamer downstream in 9 hours. Similarly, distance covered by streamer upstream in it is given that it covers the same distance upstream in 10 hours. So what will be the distance covered by the streamer upstream in 10 hours? It will be 10 multiplied by the effective speed of the streamer upstream, which is x minus 1. Now these two distance, these two distance, that is must be same. That is the distance covered by the streamer upstream and downstream, they are same. So we must have 9 into x plus 1 is equal to 10 into x minus 1. So we have to solve this equation doing the product of the LHS and RHS and expanding and opening the brackets. We get 9x plus 9 is equal to 10x minus 10. And as usual, as we have solved the linear equation, we will bring the variable terms to the left hand side and we will bring all the constant terms to the right hand side. And we get minus x is equal to minus 19. This implies x is equal to 19. That is, the speed of the streamer in the still water is 19 kilometer per hour. Okay. What is find the speed of the streamer in still water? So we have found one answer. The speed of the streamer in still water is 19 kilometer per hour, because x is what we have assumed x to be the speed of the streamer in still water. Now what will be the distance? The distance between the ports, distance between the ports will be equal to, you can consider either 9 into x plus 1 or 10 into x minus 1. I am considering to be 9 into x plus 1. So this is equal to 9 multiplied by 20, which is 180 kilometer. So the distance between the ports is 180 kilometer, and the speed of the streamer in the still water is 19 kilometer per hour. So the concept was to assume the speed of the streamer in still water as x kilometer per hour, and then you have to consider the effective speed of the streamer while it is in downstream, while it is moving downstream and in upstream. In downstream, the speed of the stream will get added to the speed of the streamer, and while moving upstream, the speed of the stream will get deducted from the speed of the streamer. And from the effective speed and the time taken to cover the distance, you have to find the distance covered in both the downstream and upstream and equate them, because the distance is the same. And hence we get the equation 9 into x plus 1 is equal to 10 into x minus 1. From here we can solve x, and x is what? X is the speed of the streamer in the still water. And from there we can say that the distance between the two ports is either we can say 9 into x plus 1 or 10 into x minus 1. Both will give the same value. So the distance between the ports is 180 kilometer. This was a little conceptual problem. Okay, let's do problem number 20. The distance between two stations is 300 kilometer. Two motorcyclists start simultaneously from the stations and move towards each other. The speed of one of them is 7 km per hour more than that of the other. If the distance between them after 2 hours of their start is 34 kilometer, find the speed of each motorcyclist. Check your solution. Okay. Okay. So the distance is given. Distance between stations is given to be 300 kilometer. We will have to assume the speed of one motorcyclist. Let speed of first motorcyclist is x kilometer per hour. This implies it is given that the speed of one of them is 7 kilometer per hour more than that of the other. So let's say the speed of the first motorcycle is let's say the speed of the first motorcyclist is x kilometer per hour. Therefore, the speed of the second, considering that the second motorcyclist is running at a high speed, will be x plus 7 kilometer per hour, because it is given that one motorcyclist is moving at a speed of 7 kilometer per hour more than the other. We have considered the slower motorcycle, the speed of the slower motorcyclist to be x kilometer per hour. Hence, the speed of the faster motorcyclist will be x plus 7 kilometer per hour. Okay. So we know the speed of the two motorcyclists in terms of x. Okay. Now, the two motorcyclists start simultaneously from the stations and move towards each other. Okay. If the distance between them after 2 hours of their start is 34 kilometer. So let's say this is the station A and this is the station B. This distance is given to be 300 kilometer. And if the distance between them after 2 hours of their start is so after 2 hours of riding, let's say after 2 hours of riding, let's say the motorcyclist starting from the station A going towards let's say the motorcyclist whose speed is x kilometer per hour is moving from station x A to B, and the motorcyclist whose speed is x plus 7 kilometer per hour is moving, let's say this motorcyclist is moving at x kilometer per hour, and the motorcyclist who is moving from station B to A is moving at a speed of x plus 7 kilometer per hour. So definitely after 2 hours, the motorcyclist who is moving from A will cover less distance because it is moving at a lesser speed. So let's say after 2 hours, the motorcyclist moving from A has reached the point C. So the distance covered by the motorcyclist moving from station A is AC, and let's say the distance, let's say the motorcyclist who is moving from station B towards A has reached the point D after 2 hours, covering a distance of BD, and the motorcyclist A and the motorcyclist running from station A to B with speed x kilometer per hour has reached the point C after 2 hours, covering a distance of AC. Now, what will be? It is given that if the distance between them after 2 hours of the start is 34 kilometer, so it is given that CD, the distance between the two motorcyclists will be obviously CD. So CD is given to be 34 kilometers. Now what is AC? AC is the distance covered by the motorcyclist running at a speed of x kilometer per hour in 2 hours. So that will be 2 multiplied by x, that is 2x kilometer will be the distance covered by the motorcyclist running at a speed of x kilometer per hour in 2 hours. What is BD? BD will be the distance covered by the motorcyclist running at a speed of x plus 7 kilometer per hour in 2 hours. So it will be 2 into x plus 7, that is twice of x plus 7 kilometer. BD is this. Now we can clearly see that AC plus CD plus BD is equal to the total distance between the two stations, which is 300 kilometer. Now this implies, what is AC? AC is 2x. What is CD? CD is 34. And what is BD? BD is 2 into x plus 7. This is equal to 300. So this is the equation we have formed from the given information. And we can clearly easily solve x. So this becomes, now I am directly solving the x. I'm not really explaining all the operations that I am doing while solving the linear equations, because I hope by now you are quite familiar and clear about how to solve a linear equation. So we have 2x plus 34 plus 2x plus 14 is equal to 300. This implies 4x is equal to 300 minus 34 minus 14, which is equal to 300 minus 48, which is equal to 252. Okay, so this implies x is equal to 252 divided by 4, which is equal to 63. X is 63. What was x? Speed of the motorcyclist. Okay, so x is 63 kilometer per hour. What has been asked? Find the speed of each motorcyclist. Okay, so the speed of the Stuart motorcyclist is 63 kilometer per hour, and therefore speed of the two motorcyclists are 63 kilometer per hour, and the other one will be 7 kilometer per hour more, that is 63 plus 7 kilometer per hour, that is 63 kilometer per hour and 70 kilometer per hour. So these are the two speeds of the two motorcyclists. Okay, let's do problem number 21. Divide 150 into 3 parts such that the second number is 5/6 the first, and the third number is 4/5 the second. Divide 150 into 3 parts such that the second number is 5/6 the first and the third number is 4/5 the second. And the third number is 4/5 the second. Okay, so total is equal to, we have to divide 150 into 3 parts. Total is equal to 150. So let first part be x. Let first part be x. Okay, Now it is given that the second into three parts such that the second number is 5/6 the first. Okay, so second part will be equal to 5/6 of the first part, that is x, which is equal to 5/6 multiplied by x. This is equal to 5x/6. This is the second part, and the first part we have assumed to be x. Now what about the third part? And it is given, and the third part is 4/5 the second. This implies third part is given to be 4/5 of the second. What is second? Second is 5x/6. So this is equal to 4/5 multiplied by 5x/6. This becomes, after answering 5, we get 4x/6. This is the third part. So the first part is x, the second part is 5x/6, and the third part is 4x/6. Clearly, their total must be equal to 150. So we must have x plus 5x plus 6 plus 4x/6 is equal to 150. Now we have to solve this equation. It is an equation, linear equation in the variable x. And what is x? X is the first part we have assumed. How do we solve this? We can see there are two rational terms, 5x/6 and 4x/6, with the denominator 6. So you can multiply both the LHS and the RHS. There are two ways you can solve this. Either you do the sum of the LHS, three terms on the LHS, or you multiply both the LHS and RHS by 6. That is the denominator, the LCM of the denominator of the rational terms. So I am multiplying both the sides by 6. X plus 5x/6 plus 4x/6 is equal to 6 multiplied by 150. So this implies, if we do the product of x and if I do the product on the LHS, if I do the product and open the brackets, I get 6x plus 30x plus not 30x, sorry, 6x plus 5x plus 4x is equal to 900. This implies the LHS becomes 15x is equal to 900. This implies x is equal to 900 divided by 15, which is equal to 60. Which is equal to x is 60, and hence x is 60. Therefore, three parts are what has been asked. Divide into three parts. Okay, so we have to find the three parts. Three parts are x. The first part is x, that is 60. The second part will be 5x/6, that is 5. X is 60 by 5. And the third part will be 4x/6, and x is 60, so 4 into 60/6, which is, the parts are 60 comma 60 sorry, this is 6, and so the second part will be 50, and the third part is 40. So 60, 50, 40 are the three parts. Okay, let's do problem number 22. Divide 4,500 into two parts such that 5% of the first part is equal to 10% of the second part. Okay, so into two parts such that 5% of the first part is equal to 10% of the second part. Okay, so let first part be x. So since we are dividing 4,500 into two parts, therefore the second part will be equal to 4,500 minus x. This is the second part. Now it is given that 5% of the first part, 5% of the first part, 5% of first part, that is x, is equal to 10% of the second part. So your concept of percentage must be well, and you must have already covered the percentage chapter in your from your previous class or in this class also. So 5% of x is equal to 10% of the second part, that is 4,500 minus x. Now 5% of x means it is equal to 5 by 100 of x is equal to 10% of something, means 10 by 100 of 4,500 minus x, and we know that the of operator means multiplication. So we get 5x by 100 is equal to 10 by 100 multiplied by 4,500 minus x. So this is the equation we got, which we need to solve. Okay. Now we can cancel out. So we see it is of the both the LHS and RHS are in the form of a rational form, where the denominators are both 100. So I would like to multiply 100 to both the LHS and the RHS, and I get this. Now after further simplification, we get 5x is equal to 10 into 4500 minus x. This implies after doing the product on the RHS and opening the brackets, we get 45000 minus 10x. Now bringing the x terms to the left hand side and constant on the right hand side, we get 5x plus 10x is equal to 45000. This implies 15x is equal to 45000. This implies x is equal to 45000 divided by 15, and this cancels. We get 3000. So x is 3000. Therefore two parts are x is 3000, and the other part will definitely be 4500 minus 3000. That is, the two parts are 3000 and 1500. Okay, let's do problem number 23. Raki's mother is 4 times as old as Raki. Okay, so this is age related problems. These are very standard problems on age. What problems on age? So Rakhi's mother is 4 times as old as Rakhi. So let Rakhi be of X years. Let age of Rakhi be X years. This implies age of mother is equal to 4 times as old as Rakhi. So 4x years. Okay. After 5 years, her mother will be after 5 years, her mother will be 3 times as old as she will be then. After 5 years. Okay. So after 5 years, age of Rakhi is equal to x plus 5 years. And after 5 years, age of mother is equal to 4x plus 5 years. Now it is given that after 5 years, her mother will be 3 times. After 5 years, her mother will be 3 times as old as she will be then. So this implies after 5 years, mother's age is 4x plus 5, and this should be 3 times the age of Rakhi after 5 years, that is x plus 5. So this is the equation we have formed in x, and we have to solve for x. So this implies if you open up the bracket and simplify the product on the right hand side, we get 4x plus 5 is equal to 3x plus 15. So this implies 4x minus 3x is equal to 15 minus 5. 15 minus 5. This implies x is equal to 10. X is equal to 10. That is the age of Rakhi is 10. So what is the age of what? Find their present ages. Find their present ages. Okay. So therefore, age of Rakhi is equal to 10 years, and age of mother is equal to 4 into 10, that is 40 years. So the present age of Rakhi is 10 years and the present age of her mother is 40 years. Okay, let's do problem number 24. Monu's father is 26 years younger than Monu's grandfather and 29 years older than Monu. So 3 persons are involved. Monu is involved, Monu's father is involved, Monu's grandfather is involved. Okay. The sum of the ages of all the 3 is 135 years. So what is the age of each of them? Okay. So let age of Monu be x years. What is given? Monu's father is 26 years younger. Monu's father is 26 years younger than Monu's grandfather and 29 years older than Monu. Okay. So this implies if we consider the age of Monu be x years, then age of father will be equal to it is given that Monu's father is 29 years older than Monu. So x plus 29 will be the age of Monu's father. Okay. This is the age of Monu's father. Okay. And it is also given Monu's father is 26 years younger than Monu's grandfather. So we can say age of grandfather will be 26 years more than Monu's father's age. So x plus 29 plus 26. This is equal to x plus 55. Okay. Okay. So we have now the age of Monu is x years, the age of father is x plus 29 years, and the age of grandfather is x plus 55 years. From here, and it is also given that the sum of the ages, the sum of all the three persons, that is Monu, Monu's father, and Monu's grandfather, is 135 years. So we can say x plus 29 plus x plus 55 is equal to 135. Is equal to 135. So we have found the equation in x. It's a linear equation in x, and we have to solve it. And we will have 3x. We will have 3x on the left hand side. We will have 3x plus 29 plus 55 is 84. This is equal to 135. And now this implies 3x is equal to 135 minus 84, which is equal to 50, which is equal to 51. Okay, this implies x is equal to 51 divided by 3, which is equal to 17. So the age of Monu is 17 years. Find the age of each of them. Okay, therefore age of Monu is 17 years. Age of father is 17 plus 29, which is equal to 46 years, and age of grandfather is equal to x plus 55, that is 17 plus 55, which is equal to 72 years. So the ages are 17 years, 46 years, and 72 years. Monu's age is 17 years, Monu's father's age is 46 years, and Monu's grandfather's age is 72 years. Let's do problem number 25. A man is 10 times older than his grandson. He is also 54 years older than him. Find their present ages. A man is 10 times older than his grandson. He is also 54 years older than him. Okay, so let's okay, so this is about two person, a man and his grandson. Okay, so let age of grandson be x years. So it is given that a man is 10 times older than his grandson. So age of man is equal to 10x years, because it is given that the age of the man is 10 times older than his grandson, and we have assumed that the age of the grandson to be x years. Okay, now it is also given that the age of the man is 54 years older than him, that is than grandson. So we can say that the age of the grandson x plus 54 should be equal to the age of the man, that is 10x. 10x. So we have formed the equation, linear equation in x. We have to solve this, and we see x minus 10x is equal to minus 54. This implies minus 9x is equal to minus 54. This implies x is equal to minus 54 by 9, which is equal to minus 54 by minus 9, which is equal to 6. So the age of grandson is 6 years. So find their present ages. Okay. So therefore, age of grandson is equal to 6 years, and age of man is equal to 10 times the grandson, that is 60 years. Let's do problem number 26. The difference between the ages of two cousins is 10 years. 15 years ago, if the elder one was twice as old as the younger one, find their present ages. Okay. So let age of younger cousin be x years. Okay, the difference between the ages of two cousins is 10 years. It is given that the difference between the two cousins is 10 years, and we have assumed that the age of the younger cousin be x years. So from here we can clearly say that age of elder cousin will be equal to elder cousin will be equal to x plus 10 years. X plus 10 years, because it is given that the difference between the elder cousin and the younger cousin is 10 years. So if the age of the younger cousin is x years, the age of the elder cousin has to be x plus 10 years. So this is their present ages. Now 15 years ago, if the okay, so 15 years ago, age of younger cousin is equal to x minus 15, and 15 years ago age of elder cousin will be equal to x plus 10 minus 15, which is equal to x minus 5. So 15 years ago the age of elder cousin is x minus 5, and 15 years ago the age of younger cousin is x minus 15. And it is given that 15 years ago, if the elder one was twice as old as the younger one, so we can clearly say that x minus 5 is equal to 2 times x minus 15, because 15 years ago the age of younger cousin was x minus 15 and the age of the elder cousin was x minus 5, and it is given that 15 years ago the elder cousin was twice as the age of the younger cousin. So we have this. So this is a linear equation in x. We can easily find x. So this implies x minus 5 is equal to 2x minus 30. This implies x minus 2x is equal to minus 30 plus 5. This implies minus x is equal to minus 25. So this implies x is equal to 25. So the age of the younger cousin is therefore ages of cousin are 25 years. That is, the age of the younger cousin is 25 years, and the age of the elder cousin is 35 years. Okay, let's do the last problem, that is problem number 27. It is given half of a herd of deer are grazing in the field and three-fourths of the remaining are playing nearby. The rest 9 are drinking water from the pond. Find the number of deer in the herd. Okay. So it is very, very important that you understand the problem statement, what information is given. If you make any mistake in understanding the information given in the problem, you will incorrectly solve it. That is, you will incorrectly assume the unknown variables, and definitely it will lead to wrong results or wrong solution. So it is super important that you understand the problem of the statement and what information is given, particularly in solving this kind of word problems on solving linear equations. So let number of deer, that is the total number of deer, be x. Okay. Now it is said that half of a herd of deer, I mean total number of deer means the number of deers in the herd of the deer is x. So half of a herd of deer are grazing in the field. Okay. So number of deer grazing is equal to half of the total number of deers, that is x by 2, where x is the total number of deer we have assumed. So number of deer grazing is x by 2. Okay. Now it is given, then 3/4 of the remaining are playing nearby. Now remaining, 3/4 of remaining, what is 3/4 of remaining? It is equal to 3/4 of what is remaining? Remaining is x minus x by 2. X is the total number of deers. Among the total number of deers, x by 2 number of deers is grazing. So what is the remaining? X minus x by 2. And it is said that 3/4 of the remaining is 3/4 of the remaining are playing. Okay. So we are finding out what is the 3/4 of remaining. So this is 3 by 4 of x minus x by 2 is x by 2. This is equal to 3x by 8. 3 by 4 of x by 2 means 3 by 4 multiplied by x by 2, which is 3x by 8. So this is 3/4 of remaining. So this implies number of deer playing, is equal to 3x by 8. Okay. The rest 9 are drinking water from the pond. So this implies, so what is the rest number of deers? Rest number of deer will be equal to the total number of deer was x, and the number of deer grazing is x by 2, and the number of deer playing is 3x by 8. So if we subtract x by 2 and 3x by 8 from the total number, we get the remaining, that is the rest number of deer. This, if you simplify, okay, so let this be, this is the rest number of deer, and it is given that the rest 9 are drinking water. So this implies we can say then x minus x by 2 minus 3x by 8 is equal to 9. So this is the equation that we have got. We have to solve this, and we see that on the LHS there are some rational terms like x by 2 and 3x by 8. So we would like to multiply both the sides by the LCM of 2 and 8, which is 8. LCM of 2 and 8 is equal to 8. We will multiply both the sides by 8 so that we get rid of rational terms in the equation. We get this. This implies if you do the product and open the brackets on the LHS, we get 8x minus 4x minus 3x is equal to 72. This implies if you further simplify, that is add the like terms, that is add the x terms, we get 8x minus 7x, that is x is equal to 72. And what was x? Let the number of deer be x. So find the number of deer in the heart. So it is 72. Number of deers in the heart is 72. So this brings to an end in solving all the problems of exercise 8A on the chapter of linear equations. The problems in exercise 8A are applications of linear equations, or you can say word problems based on solving linear equations. I hope solving these problems will give you a good idea of how to solve word problems based on linear equations, and how to understand the problem and formulate, translate the given problem statement into an equation and solve the equation by using the rules to solve the linear equation. So if this video was beneficial, then please like it, share it with your friends, and once again please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future video. The next video on this chapter will be solving the objective questions, which is exercise 8. I think I did a mistake. This was exercise this linear equations. So this was actually exercise 8B. So this was exercise 8B. So next I will solve the objective questions from exercise 8C, and finally I will solve the test paper 8. So please stay tuned for the next upcoming videos on this chapter. And as I said, I am not discussing any solved examples from the book, which are very important. Never neglect the solved examples in the textbook, whichever textbook you are following. You might be following any other textbook. Always try to solve the example problems given in the chapter, and if you yourself first, if you cannot solve, then see the solution, because those problems cover most of the variants of the problems that you need to solve for your board as well as any other competitive examinations. So that is all for this video. Thanks for watching, and until the next video, take care and bye.